The graph of the polar curve r equals 1 minus 2 cosine theta for 0 to pi is shown above. With a little bit of analysis, if you plug 0 in, you'll note that the curve kind of starts there at theta equals 0 and works its way around to this point where theta is equal to pi. Okay. Let S be the shaded region in the third quadrant of the curve and the x-axis. So this region right here. And if we think about tracing out the wedges that constitute the curve, the start point of the area is at angle 0, and the finish point of the angle is at the first polar 0. So when we're writing our integral expression for area, we start at 0 and we finish at the first polar 0. And in order to find a polar 0, we're going to set the radius equal to 0 and solve that equation. Solving this equation, we find the polar 0 occurs at pi thirds. So our shaded region goes from 0 to pi thirds. The equation for area of a shaded region of polar curves is 1/2 r squared d theta. And so in our case, our radius is that function that we're given, 1/2 1 minus 2 cosine of theta squared d theta. Now, the 1/2 can be moved to the front, and it should be noted that they just say write the expression, do not evaluate. So you're going to get 1 point for the limits and the constant. So getting that 0 to 1/3 is worth a point. And then the second point comes from having the integrand, which is basically the r squared d theta. Write expressions for dx d theta and dy d theta in terms of theta. So we should recall that x is considered to be r cosine theta. So in that case, we have the radius curve. So the expression for x is 1 minus 2 cosine theta times cosine theta. Similarly, our y curve is r sine theta, and y should be 1 minus 2 cosine theta times sine theta. This is the xy coordinate on the curve given an angle. They're asking us to find dx d theta and dy d theta. So we need to take the derivative of these with respect to theta, which requires the product rule. So then we take the derivative of each side using the product rule. Dx d theta is equal to 2 sine theta times cosine theta plus 1 minus 2 cosine theta times negative sine theta. And then we need to find dy d theta in terms of theta. So if I write dy d theta, again, this is a product, so we'll need to apply the product rule. The derivative of the first term times the second term plus the first term times the derivative of the second term. So these are, as written, acceptable for answers. The scoring rubric did go further and simplify this down because some students take different approaches, and if you simplify and combine like terms, you'll get 4 sine theta cosine theta, subtract sine theta, and then this one here, the simplification really isn't too much more simplified than what I have written down, but just to be consistent with their key, we get 2 sine squared theta plus the quantity of 1 minus 2 cosine theta times cosine theta. So when it comes to scoring the points on this one here, Your first point comes from recognizing that x equals r cosine theta and y is r sine theta. So recognizing and writing that down in either form gets you your first point. Your second point comes from finding dr d theta, and we did that when we were looking at this. So this right here is your dr d theta, and that is worth 1 point. The last 2 points come from having the correct answers. So your dy d theta and your dx d theta will be your 2 points. So we'll block that out as +2, provided what you have written down simplifies to what they have. Finally, in part C, we are being asked to find an equation in terms of an x and y for the line tangent to the graph of the polar curve at the point where theta equals pi halves. So if we're looking at this graph here at theta equals pi halves, we're at this location, and we're looking to create the equation of that tangent line. So in order to create an equation of a tangent line, one approach is to identify the point of tangency and then the slope of the tangency. So we need to evaluate what is the x value and the y value. So knowing that x is considered as above 1 minus 2 cosine theta times cosine of theta, if we're evaluating x at pi halves, we'll find that there is a x-coordinate of 0. If we do the same for the y-coordinate and evaluate the y-coordinate at pi halves, y of pi halves is equal to 1. And that's visually consistent with our graph. We see x is 0 and y is 1. 0, 1 puts us right there. So the next thing we need to create a tangent line equation is to find the slope. So we're being asked to find dy dx when theta equals pi halves. And this is going to be the same as evaluating dy d theta over dx d theta when theta is pi halves. This relies on the calculations from above for the dy d theta and the dx d theta. And if you go through plugging in pi halves into all of our thetas, you'll find that this value is equal to -2. So we now have the xy coordinate pair, xy, and the slope, so we can create a tangent line. So L of x is the y coordinate plus the slope times x minus the x coordinate. Or if you simplify that down, our tangent line is 1 minus 2x. Where do the points get scored? If you correctly found the value of the x coordinate and the y coordinate. That gets you the +1. So your xy coordinate pair, +1. The next point comes from having an expression for dy dx. So being aware that dy dx is the derivative of y with respect to theta over the dx, or the derivative of x with respect to theta. That expression right there gives us our next point. And then finally being able to construct it into a tangent line equation, that's worth 1 point. And going back and checking, it says write an equation in terms of x and y for the tangent line. Just to be safe, it's probably better that we, instead of calling it L of x, we call this y. That way our equation is in terms of x and y.